Okay, so good morning, everyone. My name is Robin Shao. I currently work in Professor Tasha Lee's lab in the University of Hong Kong. So today I feel very honored to speak here to you about a study that we did recently looking at the effects of psychopathic trait on behavioral and neuroplasticity in lying. So research in the last 2 decades has identified a neural network that's consistently recruited in lying, which consists of the prefrontal, parietal, and cerebellum networks. So this network was the foundation of our research on neuroplasticity in lying. So within this network, the rostral and dorsal anterior cingulate cortex is implicated in affective and cognitive affective processing, performance monitoring, and social decision making. The dorsal lateral prefrontal cortex is implicated in executive control functions, attention, and working memory functions. The ventrolateral prefrontal cortex and the adjacent anterior insular cortex is implicated in performance monitoring, action selection, and inhibitory control functions. And the ventral medial prefrontal cortex is implicated in affect processing and moral decision making. And also the superior and inferior parietal cortices are implicated in attention and working memory functions. And finally, the cerebellum is implicated in cognitive control, affective processing, and stimulus response learning. So despite the great amount of research that's been conducted looking at the neural processes in lying, surprisingly, very little evidence exists on whether the behavioral or neural processes of lying could be potentially trainable through practice. This is an important question both for our general understanding of cognitive neuroplasticity, but also carries very important practical implications in forensic and clinical settings. Importantly, here we consider lie capacity, similar to other cognitive abilities, could be potentially trainable. However, existing behavioral results on the trainability of lying performance is very inconsistent with a lack of neural evidence. Here we ask the key question: what factor may determine individual differences in how well they could be trained in lying? So when searching for neural correlates that could be trainable in lying and what factor may determine whether an individual could be more or less trainable in lying, it strikes to us that psychopathy, which is a personality trait that's highly associated with great lie tendency, may be such a good candidates for determining individual differences. So while high psychopaths are generally located in forensic settings, psychopathy has also been conceptualized as a personality trait that exists in a normal spectrum, and researchers have termed those high psychopaths in non-forensic settings as successful psychopaths. It has been conceptualized that successful high psychopaths are characterized by reduced affective functioning in paralimbic circuitry such as VMPFC, but also normal or even superior executive control functions in the prefrontal networks. This cognitive, affective, and neural profile of high psychopaths may make them very adapted at learning to lie. However, no existing research has looked at this question. So therefore, we conducted a study that explicitly investigated the effects of psychopathic traits on behavioral and neuroplasticity in lying. So in this study, we recruited psychologically healthy university students who were divided into either a high or low psychopathy group based on their scores on a very well-established psychopathic personality questionnaire. And all participants performed a directed lie task in which they had to give quick and honest, flexible, honest or dishonest responses on the face stimulus being presented based on a prior instructive cue. So all participants performed the task twice in the fMRI scanner, once before training and once after training, which were separated for no more than a week. During this period, all participants went through 2 training sessions, which consisted of 240 trials in total of the same task. So let's now look at the behavioral results of the study. So firstly, in the top row, the blue and the right bars respectively indicated the reaction time performance to telling truth and to telling lie respectively. So as we could see, telling lie requires longer reaction time than telling truth, and also that training indeed improved lie performance such that after training, the lie-related reaction time increase became less. And also across individuals, those participants with higher psychopathic traits displayed reduced lie-related reaction time increase compared to those with lower psychopathic traits. And in the plot in the lower row, the blue and the right bars respectively indicated participants' reaction time to telling truth and to telling lie in low psychopathic participants, and those in green and purple bars display participants' reaction time when telling truth and telling lie for high psychopathic participants. So here, a very important theory interaction of lie times training times psychopathy indicated that only high psychopathic participants displayed reduction of lie-related reaction time after training. In contrast, no such reduction was observed in low psychopathic participants. Let's now look at people's neural responses during the cue phase. The cue indicates whether the participants need to make an honest or dishonest response on that trial. So participants' neural responses to the cue could indicate a general response preparatory signal for the upcoming lie-telling response. So in the top row, it depicts a region of the right lateral posterior parietal cortex where signals show significant lie times psychopathy interactive effects. So in the middle graph, the blue and the right bars respectively indicated, again, neural signals to telling truth and to telling lie. So as we could see that this signal was greater for lie instructive cue compared to truth instructive cue, but only for low psychopathic participants, not for high psychopathic participants. Also, that this signal to lie versus truth instructive cue possibly predicted inter-subject variance in lie-related reaction time. And secondly, across three regions of interest, including the bilateral cerebellum, the dorsolateral prefrontal cortex, and the ventromedial prefrontal cortex, signals displayed a significant lie times training times psychopathy effect. So in the middle plot, the low psychopathy participants were displayed on the left, and the high psychopathy participants are displayed on the right. And the blue and the right bar indicates participants' neural signals to truth instructive cue and to lie instructive cue before training. And the green and purple bars indicate participants' responses to true and to lie cues after training. So as we could see from this graph, there's a consistent pattern that the signals to lie versus truth instructive cue reduced after training compared to before training, but only for high psychopathy participants, not for low psychopathy participants. And again, these signals have behavioral significance because the reduction of signals to lie versus truth instructive cue after training possibly predicted inter-participant variance in the reduction of lie-related reaction time after training. So these results generally suggest that only high psychopathy participants display a neuroplasticity during the response preparatory phase, where signals when processing lie-related cues show a reduction, which were very closely tied to their improvement of lie performance. However, such reduction was not observed for low psychopathy participants. So now let's look at people's neural signals during the response-making phase, where the pattern results were very similar to the pattern results during the cue phase. So across three regions of interest, including the ventrolateral prefrontal cortex insular network, the ACC, which is not shown on this figure, and also the cerebellum, participant signals during lie telling compared to during truth telling reduced after training compared to before training. But again, this pattern was only observed for high psychopathy participants, not for low psychopathy participants. So as characterized by an important three-way interaction of lie times training times psychopathy. And once again, these signals had behavioral significance as reduction of lie-related signals after training possibly predicted across participant variants in the reduction of lie-related reaction time. So in general, our results indicating very key modulating role of psychopathic traits in modulating individual differences in behavioral and neuroplasticity in lying. And given we did not find difference between high and low psychopathic participants before training and their difference only emerged after training, our results seem to indicate that rather than having a greater natural ability to lie for high psychopaths, those individuals may rather be characterized by a greater ability to learn to lie. On a neural level, during response preparation, we found high psychopathy-specific neuroplasticity in both the dorsolateral and ventral medial prefrontal cortices, respectively implicated in higher level cognitive control and affective processing functions, and also in the cerebellum, which is implicated in a diversity of functions, including cognitive control, affective regulation, and pattern learning. And similarly, during the response-making phase, neuroplasticity that was only observed for high psychopathy participants were observed in the ACC and in the VRPFC, regions commonly associated with action selection and performance monitoring. Very importantly, all these signals were very closely associated with participants' improvement in behavioral measures during lying, and in contrast, the low psychopathy participants displayed no improvement in lie behavioral performance and no reduction of lie-related neurosignals due to training. So collectively, these results indicate that training shifted the neural responses during lying from a very effortful, higher-level cognitive control-based process to a relatively low-effort automatic process, but only in high psychopathy participants, not in low psychopathy participants. And this psychopathy-specific neuroplasticity may be related to the conceptualization of high psychopaths as demonstrating an imbalance of relatively high level of cold executive control functions, but reduced level of hot affective functions. And finally, our results have some general implications. So given that we observed behavioral and neuroplasticity in high psychopaths, our results suggest that the great lie tendency commonly associated with high psychopathy may be a joint effect of innate mechanisms and late life experiences. So this opens the ground for potential behavioral-based intervention on maladaptive psychopathic trait. And secondly, our results generally indicate a very close interplay between cognitive and affective systems in neuroplasticity, and we also emphasize the importance of individual differences in personality traits in modulating neuroplasticity. Thank you very much for listening.
Thank you, Robin.